back, ladies and gentlemen, to another exciting lesson in Algebra 1. Yesterday we were talking about the multiplication property of exponents. Today we will be discussing the division property of exponents. So, what if we are trying to find the quotient of powers? Now remember, quotient has to deal with division. So yesterday we were multiplying exponents with the same base. Today we are going to be dividing them. And there's another pattern that's going on. We want to figure out what it is. So let's again look at the expansion of this and see what that pattern is. 2 to the 7th is saying 2 times itself 7 times. 1, 2, 3, 4, 5, 6, 7. Okay? And then on the bottom, 2 to the 4th, on the denominator, 2 to the 4th, 2 times itself 4 times. Well, notice, I've got 2's on the top and 2's on the bottom, which means that I can cancel out what's in common when things are being multiplied together. So there's one gone, there's another gone, one more gone, and then last but not least, I can't cancel out anymore. So what's left? 2 times 2 times 2, which is 2 to the 3rd power, which is 8. So let's look primarily at my new exponent, which is 3. How do I get 3 from 7 and 4? Well, notice what we can do. We can take 7 minus 4 to give me 3. So when I've got the same base raised to exponents, I'm dividing them. What I can do is I want to subtract the exponents. And that is what our table in our notes is going to show us. Give us a couple more examples involving variables. So as always, make sure you check out these examples, read their definition, see how they symbolically represent it. If you can understand all those, you're going to be good to go. So let's look at a couple of examples. Simplify each expression. Assume that no denominator. Sorry, that's supposed to say that. Change that in the notes. Assume that no denominator equals 0. Because remember, we can't have 0 in our denominator or else we're going to be undefined. So we want to break this up the same way we broke it up yesterday when we were multiplying. So I've got x to the 7th, y to the 12th, all over x to the 6th, y to the 3rd. I want to break those up into involving my x's and involving my y's. Because when I break it up, it makes it a little bit easier. I can see for the x's, my base is going to stay x. 7 minus 6 is 1. When my exponent is 1, remember, I don't need to write down that 1. It's understood that there's a 1 here. So remember, I do not need to write that down. And then, on the y's, I've got y to the 12th divided by y to the 3rd. So I'm going to keep my y variable as my base. I'm going to take 12 minus 3, and that's going to give me 9. So what I started with, simplified down, is going to be x, y to the 9th. And there's multiplication happening there. In my second example, I want to do the same exact thing. Break it up in terms of the a's. And then the b's. Sorry, it's a little mismatched there in terms of size. Let me try that again. All right, so break it up into those groups and then just go group by group. A to the 3rd divided by a. If I subtract those exponents, remember there's a 1 there. That's going to give me a squared. B to the 9th divided by b squared. Base is b. 9 minus 2 is going to give me 7. And then I've got c over c. Remember, when I got c over c, this is going to go away. This is going to go away. So my final answer is going to be a squared b to the 7th. And the c's just cancel out. And we'll look a little bit later on why we know for sure that those are going to cancel out. So another thing we need to look at today is what if we have a quotient raised to a power? So once again, I want to look at what this is going to look like. This is going to say 3/4 raised to the third power. So what I'm going to do is I'm going to take 3/4 times itself 3 times. And when I use what we've talked about when I multiply bases together, how we can add their exponents, this is going to simplify to give me 3 cubed over 4 cubed, because I'm going to add all these exponents. I'm going to add all those exponents together. So it's going to end up giving me 3 cubed over 4 cubed. So what is the pattern? What could I have done from the get-go so that I could cut out this middle step when I simplify? Well, I can take that exponent and I can apply it to the numerator and I can apply it to the denominator. So what's the pattern? Apply the exponent to the numerator and the denominator. And denominator. Again, gave you the textbook, what they said for the same exact thing, with a couple more examples. Let's look at a couple examples of our own. Again, we don't want to have any denominator as 0, so we're just going to assume that no denominator equals 0. And let's start with a. So what I need to do with this exponent of 2 is apply it to the numerator and the denominator. So I've got 3p cubed, and then that's being raised to the second power, over 7 raised to the second power. Now make sure, as you can see, what I did in the numerator is I put 3p cubed, I put that in parentheses, because this is going to throw us back to what we did yesterday. I need to take this exponent of 2 and apply it to everything inside of those parentheses. So that's going to give me 3 squared and then p cubed raised to the second power all over 7 squared. And now I'm going to start simplifying this. So I've got 3 squared, which is 9, p cubed to the second power. Remember, when I take power to a power, I need to multiply those variables together. And on the bottom, 7 squared gives me 49. And that is that simplified answer. Same idea over here. I need to apply that 3 to the numerator and the denominator. So put your numerator in parentheses, apply that exponent of 3, put your denominator in parentheses, and apply that exponent of 3. Use your power to a power rule. Scroll down. So for the numerator, I've got 3 cubed, m cubed raised to the third power, and squared raised to the third power. And in my denominator, I've got 4 cubed, and then p to the fifth raised to the third power. So let's finish this out. Use our calculators if you need to. 3 cubed, that's going to give you 27. M to the third, multiply those together, gives you m to the ninth. N to the second to the third is going to give you n to the sixth, all over 4 cubed. That's going to give me 64, I believe, 64. And then p to the fifth to the third is going to give me p to the 15th power. Take a step back, see if you can simplify anything anymore. If there are any variables that are the same, that you can subtract their exponents, or look at the numbers and see if you can reduce those. Nothing I can do here, so that's going to be our final answer. Make sure you write down questions if you have any. That way we can answer those when we get to class. All right, we have one more concept we need to cover, and that is, what if an exponent is 0? Remember, well, not remember, because I'm telling you now, anything raised to the 0 power is always 1. Always, always, always. Anything raised to the 0 power is always going to give you an output of 1. So for example, why if we looked at 2 to the 0, why does 2 to the 0 equal 1? Well, let's look at 2 to the third over 2 to the third. So 2 to the third over 2 to the third. Well, you know, when it's the same thing on top and the same thing on bottom, that cancels out and gives you 1. But let's look at what is happening if I expand this out. 2 times 2 times 2, all over 2 times 2 times 2. Well, all of these 2's on the top and the bottom are going to cancel, leaving you with just 1. We can also look at 2 to the third over 2 to the third, and this was kind of like that C over C case a couple of examples ago. 2 to the third over 2 to the third. Well, if I use the division property, which says if I have the same base, I subtract the exponents, that's going to give me 2 to the 0, which is 1, because then we just learned that from the red step. So those are a couple of reasons why 2 to the 0, or anything raised to the 0 power, is always going to be 1. Another chart with a couple other examples where you get to see that in motion. And let's finish it out with 2 more examples. So, look at A. That looks complicated, right? You've got m's, n's, numbers, all types of different exponents. Don't worry about what's going on inside those parentheses when you have an exponent of 0. Like I said, anything raised to the 0 power is 1. So we're taking this whole group and we're raising it to the 0 power. My answer is 1. There's nothing else I have to do. I don't need to simplify anything that's going on inside those parentheses. So you always want to look at those exponents to see what's going on. Now in B, it's a little bit different because I'm not raising the whole thing to the 0 power. All I'm doing is raising the m to the 0 power. Well, m to the 0 power is just 1. So what I really have going on here is, is n cubed over n squared. The 1 went away. So now let's use what we learned about the division property. N to the third divided by n squared. I subtract those exponents, and I'm just left with n. So I hope you learned something today in today's lesson. If you are struggling with anything, make sure you come in to AIM or ask questions during class, something along those lines, so we can make sure we're finding success early on in semester 2. You've got some You Try Now problems in your notes. As always, make sure you have those done by the next time I see you in class. That way we can go over those and start something new. All right, as always, I hope you have a fantastic evening, and I look forward to seeing you all soon.